these two men are two of the greatest offensive centers in the history of the National Football League. They both had long careers and suffered many injuries, including many concussions in the course of those careers. But they had very different experiences after they retired. So the man on the left is Jim Otto. He's 86 years old. He's very outspoken about the medical consequences of playing football at that level, but he's never disclosed a diagnosis of dementia. The man on the right is Michael Webster, and he developed dementia in his 40s and tragically died at the age of 50. And upon autopsy was diagnosed with chronic traumatic encephalopathy, which is a form of dementia caused by traumatic brain injury, or TBI. And this is the great challenge, in my opinion, in TBI, is this enormous diversity in people who've had similar injuries but have very different outcomes. And it's heartbreaking in some ways, but it's also very exciting because there are people out there who can overcome these events. They have the answers in their heads. And so the challenge that I'm excited about is how to get those answers out of their heads and deliver them to the people who need them. And we can use stem cells to do that. So you can take skin cells from a patient and turn them into stem cells, and then turn those stem cells into brain cells. And we can grow those. The nice thing about that is those brain cells retain the genetic identity of the person they came from. So we can grow them in these three-dimensional clusters called organoids. This is a video of an organoid that we've labeled with a stain that gets brighter when a cell activates. So you can see these synchronized bursts because the cells are connecting to their neighbors like they're supposed to. And these patterns don't mean anything. This isn't a real brain. But in the brain of a living person, these patterns are feelings and memories and decisions and personality until trauma scrambles the picture. And we know something about how that happens because there's great data in the literature about how the brain deforms and moves during a traumatic brain injury event. What we've done as a mechanical engineering team is we've created this machine that can reproduce those deformations in an organoid. And that allows us to take this disease out of the chaos of the real world and recreate it in the very controlled and standardized environment of our lab. So we can see the power plants that fuel the cells shutting down. And we can see the synapses that stitch those neurons together into meaningful circuits disconnecting and disintegrating. And that allows us to interrogate this condition and hopefully get the answers that will allow us to help the patients who need that assistance. Thank you very much.